In the voice AI community, from what I see, the go-to solution for workflow automation is either N8N or make.com. Now, both these platforms are amazing. In fact, I use them in my day-to-day pretty often. However, in my opinion, they are not the best solution for workflow automation. Firstly, they are relatively expensive. 10,000 operations on make.com costs around $15 per month, depending on the plan that you choose. Whilst this number does sound like quite a lot, when you start having scenarios that take 10, 20, 30 operations per run, this number becomes a lot smaller pretty quickly. They also, and this might sound counterintuitive, are very difficult to master. Building a simple scenario is easy. Trying to build something difficult with a ton of nuance is extremely complicated and takes a lot of digging through their documentation. My final reason as to why I just think they aren't the best solution is the fact that you get a ton less leverage with AI when you're using them. Obviously, most of us think that LLMs are useful, helpful, and should be used in the day-to-day. And our LLMs that we currently use have thousands of times less training data about N8N or make.com compared to something like standard code, which they are extremely well versed in. So what is the best way to do workflow automation in my opinion? How much does it cost? And how difficult is it to actually do? The solution is Python code. In my opinion, Python is the most simple and easy to read language. And since we don't have to worry about front-end development, which Python sucks at, this is the best language for backend. Now, if you've never coded before, stick with me, as I know code can sound a bit daunting, but I promise you from experience, as someone that didn't know anything about coding just over a year ago, it's actually surprisingly easy to get an understanding of the basics, especially with a good LLM by your side. Okay, so instead of just telling you how easy it is and going through things, I'm going to show you instead. What we're going to do is we're going to take a make.com scenario that I've built specifically for this video. I'm going to explain the scenario, show you exactly what is happening in the backend and what the automation is doing. And then I'm going to move it to code, deploy it to the cloud, and have it working in probably 15 minutes to show you just how easy and simple code really can be. What we're doing, or the scenario that I have copied in make.com, is a function for checking availability, just like Retail AI handles for us default. I don't know if that makes sense, but essentially Retail has this check calendar availability. You plug in your cow.com, you give them your API, and it checks availability for you. So can you do tomorrow, please? And basically it's going to check availability for tomorrow, give us back a result, and we will see kind of what it looks like. So it inputs start time tomorrow 12 a.m. and end time tomorrow 11:59 p.m. As you can see, it is in natural language. So clearly they're doing some processing behind the scenes in order to get it to the correct date format for, checking things with cow.com. And then we get back something like this. So it's availability for selected time, date Friday 2025, May 9th, which is what the date is, from 9 a.m. to 10 a.m., then from 10:30 to 11:30, then from 1 to 4, and then from 5 to 6, 7:30 to 9 p.m. So a ton of different availability ranges, and that's our availability. So we need to have our function to take natural language, check availability based on cow.com. And as we can see on my calendar right here, on Friday, I've just added some stuff in the way in order to block up my calendar. And essentially that's where the availability is coming from. So clearly the availability is correct. And what we are doing is replicating this within this function right here. So what we do is we take the start time and end time, which will be in natural language, pass it to an LLM, specifically Llama 4 Maverick, in case you wanted to know. We give it a prompt to take that natural language and turn it into an ISO 8601 date. It does it in a JSON. We also input obviously the day today and the day now, because it needs to know that in order to know what is tomorrow. And then it responds in a JSON format. We then pass that JSON. So as you can see, we input the result from the Llama 4 Maverick. Then what we do is we send that start time and end time to api.cow.com v2 slots, which basically just gives us back a ton of data that tells us what slots we have free. Then we escape that JSON. So basically, because we get back a JSON from cow.com, we wouldn't be able to send that to Grok or to Llama 4 because it basically needs things to be sent as a string. So we have to escape the JSON. Unfortunately, make.com doesn't like support any sort of inbuilt escaping function, so we had to do it ourselves. Then we send that to another LLM step, which basically formats those slots into the format which we want, which is this availability for selected time, date, the date, and then the availability range, which we saw in Retail AI. Then we create a JSON, and then which is the VAPI format, just because imagine we're doing this for VAPI. And then we send back our webhook response, which all comes out to around 8 operations, and that's our tool. So ideally, in this kind of function, we wouldn't be using any sort of LLM steps. I've said this many times before, but ideally you use as much code as possible. It is quicker, obviously cheaper, and it has no issues when it comes to hallucinations. Obviously you're using actual code, which is determinist. So I've just opened up Cursor, and now let's replicate this code and get it uploaded into the cloud so that we can start using it just like a make.com scenario. Okay, so I've just created a new folder. I've called it replace make.com and N8N. I'm gonna create a new file, check_availability.py, because we're gonna be using Python. Then I need to create a virtual environment. So here, as you can see, we have select interpreter, create virtual environment, venv, and then choose this one. It doesn't really matter too much which Python version you use. It's gonna now load. So the first thing I know that we're gonna need to use, and I know already roughly what frameworks we're gonna use to build this. And like I said, it's gonna be very, very simple, and I'm gonna explain it very easy for you to understand. We're gonna be using Fast API. So this is the framework. Imagine it, Fast API as just make.com. Fast API allows you to create an app, and then within that app, you can create different routes. So like, let's say /check_availability or hello, and then / that, whatever. It allows you to create multiple routes for a specific app. So we're going to use Fast API as it's also natively asynchronous, which basically means that you can send multiple requests to it at once, and it can handle multiple requests at once, which is really, really useful in case, you know, our agents or whatever we're using in production needs to run multiple times at once. So since I know we're using Fast API, I can do from Fast API import Fast API, and also we need request. Next, and by the way, this is just like the imports. I haven't installed anything yet, so we're going to install some things in a second. Next, I also know we're going to need to import HTTPX. So imagine HTTPX as literally just the HTTP module in make.com. It's the exact same thing, and it is the best way to handle sending requests or getting requests, whatever it be, in Python code. The next thing we're going to need is dates, because I know we're going to use different dates. So I'm going to do import datetime, and that's it. And we can now initialize our app just like the code is expecting me to do. And we can do app.get just exactly like this. And we can just do that. We can get rid of this because we don't need that. And we can also move this one to the left. Okay, so now we have at app.get /check_availability. Then it takes the request data, and so request.json, and puts that data or that request data into the data variable. Sorry for the loud noise if you can hear that. So now once we have that data in that variable, we can do whatever we want to do when someone sends a request to check availability. Now, one thing I do need to change is from get to post, because we're not using get. We're going to be using post instead. Now within this data, we're going to have start time and end time. So we can already do start_time equals data.get start time, and then end time is data.get end time. So now we could print, let's say we printed the start time and end time, and we would get back tomorrow at 8 a.m. and tomorrow at 11 p.m., for example, because that's what we have currently. This is where the natural language would be. Now what we want to do is we want to take that natural language and turn it into a real date ISO 8601 format. Ideally, not using an LLM like we did in the make.com scenario. So to do this, we're going to be using a GitHub framework or a Python framework, called Recurrent. Essentially, it's a Python library for natural language parsing and formatting of dates. It's very, very simple. As you can see, it has a ton of examples. If you say next Tuesday, it'll give you the date for it. If you say tomorrow, it'll give you the date for it, etc. It just handles everything we need, and it's exactly what we need. So as you can see, it's only using Python, which basically means we're not using any LLMs or anything like that, which makes it quick and reliable. So what we can do is we can go into here and do pip install recurrent. Okay, so the terminal wasn't working for a second. I just restarted the virtual environment for whatever reason. There was some issues, but then I pip installed recurrent and now it installed correctly. So now the next thing we can do is we can just go into the documentation real quick and see what we need to do for our imports. It is very, very simple. As you can see right here, we have from recurrent.event_parser. And then why is it not pasting? That is so weird. Import recurring event. So let me copy this. Let me paste it in. There we go. This time it worked. And from the documentation, we can kind of see what we need to do, which is we need to initialize the client, basically doing r equals recurring event, and then the now date, which basically is just telling the client or recurrent what is the date right now. So if I said tomorrow, obviously the day that recurrent is going to be outputting is going to be different depending on what we're kind of wanting the date to be as now. So if I wanted to see, in 2010, if someone said tomorrow, what would the date be? Then I could do that, but obviously we're going to make it as today and now. So what we can do is we can do within slash check availability, we can do r equals recurring event and then not data.get. This is just autocorrect. We want now underscore date equals, and then we can do date time dot now and close the brackets. Perfect. Then we do r.parse start time, exactly like it's done, and r.parse end time, just like this. And now what we could do is we could print these dates and basically just see if we've got the right things. Oh, sorry, we want to do this start underscore time equals. Basically, we're trying to update the variables with the correct date time. So we can now do end underscore time equals r.parse. And now we could print these two things and just see what we're returning. So what I'm also going to do is if name equals main, if name equals main, import uvicorn, and then uvicorn run app host and port 8000. So basically what now happens, if I do Python check availability and just run this script, it's going to start up our fast API server using uvicorn. It's going to use that to run the server or the app. And then from there, we can now send data and send requests to our local host. So that means no one else will be able to send data to it for now, but ourselves. And then we can test our app and what it's doing in the backend. So first, I just need to install the things that we are using. So pip install fast API, and then we can pip install HTTPX. There we go. I believe that's everything that we need for now. Then we can do Python check underscore availability.py, run that. Oh, yes, uvicorn, that's the issue. We can install this quickly and then we can run it now. There we go. So now we have our server running in localhost. What I will do is grab this and I will say, give me a curl command to this. No, not that. I'm just going to say localhost 8000 with start time being tomorrow 8 a.m. and end time being tomorrow 11 p.m. So it's going to give us a post request to the thing. We can just copy it, open up our terminal, In fact, we could just run it here. And now we get back this message availability checked, which is perfect because it says return message availability checked. But if we go back to our Python, we will see here the printing of the date. So obviously you saw we inputted tomorrow 8 a.m. and tomorrow 11 p.m. And from our printing, we can see that our recurring event did the correct thing, which is take the natural language and take it into the correct date format. So as you can see here, we have 2025, 05, 09, and then 8 a.m. And then same 2025, 05, 09, 23, meaning 11 p.m. So that's perfect. The next thing we want to do is format this just a little bit because cow.com expects a different format. So what we can do is start time equals, and then start time dot string, but we need it like this, I believe. And then we need T. So I believe it's like that. Essentially, it's just the correct ISO 8601 format, which cow.com expects. In fact, I'm just going to ask, will this be ISO 8601 format? We can get a response. And in the meantime, what we can do is we can define a function. So the next function is going to be, the next function that we need is to get to the availability. So as you can see, I mean, it's already kind of doing a lot of the work for me. We want get availability, start time. We don't need this. This is irrelevant. And end time. Yes, it is the correct format. So cool. Then what we want to do is, in fact, I'm going to cheat our way a bit and just show you how quick we can do this. I'm going to copy this module. I'm going to paste this in just because it gives you a JSON, which make.com already gives you. I'm going to say use start time. I can't even spell, but it doesn't matter too much. And end for this, and add this logic in get underscore availability. Use HTTPX. Simple as that. Now it's going to do its thing. It's basically going to write some code within here, and it's going to make the URL the correct URL, which will be, cow.com v2 slots. It will do it all for us. We don't have to worry anything about it. There you go. Async with httpx.async client as client, start time as our start time, end time as our end time, etc. We can simply put accept, and we can go from there. So now what it's actually done is it's even inputted it into the fast API route, which basically takes the end time and start time that is now been formatted, and then get the availability. So we can do accept. We can now save this, and we can close this application that we were running and reload it and show you what it shows me, and then see what the logic looks like now. Okay, so if you have an issue, so if I were to try to restart this app, it's going to say there's an error because the local host we're using and port 8000 already has something there. Just use this command right here. It's going to kill whatever was running on that port, and now we can restart it. Or you can even just do reload equals true, and that should work now. So let's run this. You must pass the application as an import. So, okay, got you. So I think what we need to do is put in here, check availability app like that, and that should work. Yes, okay, cool. So it works. I can just stop this from running because we don't need to change anything. So now it's reloading. So if I press save, as you can see, it's reloading down here at the bottom, which basically means we can work with things, reload it, and then test it, and we can get things live. So I'm going to load older messages, grab this curl request, chuck it into my terminal, and we can see what we get back from this. There we go. So we got back our availability dates right here, which is all the dates we get from cow.com. So clearly we've taken the start, or taken the natural language start time, end time, turned it into an ISO 8601 format by using this Python framework called Recurrent. Then we sent that off to cow.com, and we received our availability, that being this data right here, which shows us all these slots that are available. So what we're going to do is we're going to grab all this data, and basically tell our LLM, this is what we get back from cow.com. It's going to understand that. Now we want to format it like this. And I'm going to grab the example that we had in our prompt, which is like this. Grab that. We also want to, okay, actually, you know what? We can just send that now. Please turn this into a function called format availability. I've misspelled it, but it will understand. So now what it's going to do is going to create a function that takes that static cow.com data and turns it into a nice format. And it's going to be able to do this every time. So it's not an LLM step. It's going to understand the way that the data looks like, what it needs to do within the function. And then from there, based on that example, it's going to be able to run this stuff in order to format it every time. So now what we can do is we can just press accept file. I'll just assume that it's done it correctly. As you can see, we got back our function. So I'm going to just like make this smaller. Something we do need to do is make this async. I'm actually gonna, it should be fine there. So what I'm gonna do is now, after getting the availability, we're gonna do formatted availability, await format availability, and we're gonna print the formatted availability instead and see if this works for us now. So let's run this, see if it works first try. Okay, no, it didn't work first try. So what we can do is we can grab this, take this error and basically just send it to the composer. Don't even need to write anything else. It's going to figure out what the issue was. We're going to give it a second to cook. It's doing some thinking and now it's writing some code, so we can take a look at the thoughts. The main error is type error argument of type coroutine is not iterable, which is happening when trying to check if data not in cow response in the format availability function. Whatever, I'm not too certain. It's basically changed it from async to not async, but I want the function to be async. So that was the issue, but that's because it didn't understand. So the user wants the format availability function to be async. So now it's going to change things differently in order to keep it async whilst fixing that error. So let's give it a second. Again, see what it changes here. As you can see, we're already like 80% of the way done with the scenario. I think I've been working on this for like 15 minutes now. I could probably get it done quicker as well if I wasn't talking. So let's take a look at what it's doing. So we want to keep this there. And then instead of availability, we want formatted availability. What else has it changed? It has changed stuff within get availability. Okay. So it's instantly doing it within get availability. Okay, so we can just do availability and it formats it within the function itself. So let's get rid of this like that, reload and run this request and see if it's done it correctly now. There we go. So we've got it done correctly. Amazing. A little bit of fixing, like one error, and then you send it to the LLM and it gets it done for you every time. So now we get back this beautifully formatted availability. In fact, I'm going to quickly just make this even better for us by just literally printing out only the availability. I don't want anything else, just so it's a little bit easier for us to see. We can rerun this request. Oh, okay, it's a dictionary. Okay, we're just going to leave it then. I'm not trying to mess around with this too much for now. Okay, so we get back this availability right here. Availability for selected time, date Friday 2025, May 9th, which is what the day is. Then we have from 9 a.m. to 1 a.m. Sorry, to 10 a.m. It looks weird for a second. From 10:30 to 11:30, from 1 to 4, from 5 to 6:30, and then from 7:30 to 9. So if we were to look at retail, what do we have here? From 9 a.m. to 10 a.m., that's the same. From 10:30 to 11:30, that's the same. From 1 p.m. to 4 p.m. that's the same. From 5 p.m. to 6:30 p.m. that's the same. And then from 7:30 to 9 p.m. in the exact same format, our function is done. Okay, so to deploy it, what we need to do, apart from this Python file that we have, which works perfectly now, we also need to add a requirements file. So essentially what you can just add into your agent, just say, give me a you can even just do that, requirements file with no version numbers, please. And then we can run that. It's going to create a file called requirements.txt. And then it's basically going to put in the things that we need. So that was fast API, Unicorn, HTTPX, and recurrent. We can press accept. And now what we need to do in order to get this onto the internet, so currently it's only locally, we need to basically send this to GitHub into a GitHub repository. And then from there, it can be sent to render. So what we want to do here is we want to go into Arc, or into your browser, sorry, open up GitHub and create a new repository. So I'm going to call this check_availability. The repository check_availability already exists. So let's just do one. Cool, perfect, private. And we can create this repository. Once we've created it, we're going to grab this URL right here and take this to our cursor and basically say, can you initialize a git? Then can you add check_availability and requirements.txt to it? Then can you commit and push to, and then input the URL. So now it's going to give me some commands, which we're just going to run into the agent section, which is what makes Cursor so good as well. You just press run. It now has initialized an empty Git repository. Then it's going to add check availability and requirements.txt. Done. Now it's going to configure the stuff. So essentially, no, we're going to skip this one. I don't need to do all that. That's not useful. Yes, there we go. Commit, initial commit with check availability API. It's going to commit it, and now we're going to push it to the repository. So add it first and then push. Let's get the last one, and then we go. We get push, and now we're done. So now we can go into GitHub, we can reload this, and we're going to see check availability and requirements.txt in our GitHub. There we go. So the next thing we want to do is go into render.com, sign up to this platform. Like I said, it's free. And once you've signed up, you're going to be put into this like project section. We're going to press add new web service. And then within here, you're going to connect your GitHub and then select the repository that you just created. So we're going to name this check availability if possible. Then the language should select naturally by yourself. The branch, this is not important. If you did what I did, the only branch that should be there should be main. Then we have Frankfurt, or a bunch of different regions, so you can deploy on Virginia, Frankfurt, Singapore, Ohio, and Oregon. I'm going to just choose Frankfurt because I'm in the UK, so it's a little closer to me. Next thing we need to do is get a start command. So can you give me a start command for render, please? Don't make it a file, just copy and paste. Cool, so it's going to give me a start command, which we're just going to paste in here. It's likely going to be something like Unicorn, check_availability. It's going to be something like this. In fact, it probably is exactly like this. Let's take a look. Yeah, it looks like it's exactly this. So yes, okay, so no, the difference is we need to do $port. Then for the instance type, we're going to make it free, obviously. The few benefits or kind of negatives, I guess, of the free is that after a certain amount of time, free instances spin down. So basically what this means is that after a certain amount of time of inactivity, I believe it is 15 minutes, the instance will spin down and then spin back up. So essentially, if you were to call the API, it might take 3 seconds, 4 seconds, 5 seconds to respond, which will usually cause a timeout and therefore an error in the sense that you're gonna have to wait for it to spin back up and then you can send things to it normally. If you don't want that, you're gonna have to go into the starter plan, which is $7 a month. Now, again, because with 512 megabytes of RAM and 0.5 CPU, you get a lot of compute, for backend and workflow automation. Since we're not doing much, we're just sending requests like HTTPX, and just like the things we're doing in make.com really don't take a lot of RAM or CPU compute. You know, you can have multiple tools or multiple scenarios on one instance type, which makes it really, really useful. I'm going to make it free for now just because we don't need anything else. And for the environment variables, we don't need any since we're not using any, and we can literally just press deploy web service. Now what's going to happen is Render is going to build our logs. Basically, it's going to build all the code we have on its computers, because obviously it's now building stuff on its computers. And then what we can do is we can grab this HTTP URL we have here, which is exposed now to the internet. So basically our code is almost ready to be ran. What I'm going to do is, can you give me that curl request, but using this URL instead. So now we're going to ask for a new curl request with the new URL. It's just going to give me exactly what we were testing with before, and now we can test it on the internet. Okay, so it's live now. It's all done, the building. It should be like 5 minutes at max to do. And now we can send our request. As you can see, we are sending it to HTTPS check availability dot on render. So let's take a look, and we get our response back. Message availability checked, availability for selected time from 9 a.m. to 10 a.m. and then 10:30, etc. And just to be certain, what we can do to just show you the fact that this is working, we can make it, I don't know, next Thursday. So instead, we're going to do next Thursday, which is exactly a week from now. And today is the 8th of May. So it should output 15th of May, if I can do my maths correct. I think 8 plus 7 is 15. So there we go. Yeah, there we go. Thursday, 15th of May, availability from 9 a.m. to 9 p.m. because I don't have anything on my calendar on Thursday. I try to keep my calendar as empty as possible so that I can be fluid and flexible. Cool. There we go. We have taken a make.com scenario and pushed it to Render. And now we have this for free on render.com running, and we can simply add more and more code. Essentially, it's just so simple. What we can do is add a ton more code. Let's say we want another scenario in here. So, we can just get rid of this for now. We could have @app.post. I don't know. Let's say we want book appointment in this scenario. So we could have book_appointment. And in here, we would also add the logic for booking an appointment. And then after that, we would just push it to the GitHub again. So kind of update our GitHub, and then it would either auto deploy the last commit, or you could press deploy last commit or latest commit, sorry, and it would reload everything, and the build would be a lot quicker because it has cache and it'll just be quicker. And from there, you have your updated code and it's ready to run again. Now, I specifically use this for a lot of my client work when I'm building tools, because tools usually are on make.com. Well, that's what most people do. And first of all, it's a bit slower, has way less ability to change things. On Python, I can use absolutely anything I want here, and there are millions of frameworks. Code is just better than make.com.